All right, so the thing we're going to do today is I'm going to go through some of the questions on the last test. You're going to have the opportunity to make corrections. Your choice is going to be this. You can make the corrections and turn them in for half credit back. So in other words, the test is worth 30 and you got 15 and you do all of the questions correctly, 15, you get 7.5 back. So that would give you 12. You would get 7 plus 15, so 22 out of 30. So that's one option. Or you can do the corrections and you can know that you got them right and know that you can do it again and get a higher score because you'll get full credit for everything that you submit or that you do for your retake. So those are your options, but you need to do the corrections. So we're going to go over similar problems to those that are on the test. Now, I'm not going to go over the vocabulary. The vocabulary we went over in class. You have it in your notes, or you should. If you do not, then there's a website called mathwords.com, and you can get the vocabulary there. Now, if you are just doing corrections and you want to get points back for your vocabulary, the only way to do that is you must rewrite the definition, full definition, and then show it in an example. Okay, so using that. Okay, so in order to get points on your vocabulary, and again, it is half credit points for your corrections. You have to, whatever words you got incorrect, you must rewrite the definition, not the definition that is on the list, but a full definition from mathwords.com, from a book, whatever, in your own words, okay, and then show an example. That's the only way to get points back on the vocabulary. So that's your choice, but that's how you're going to do that. And if you need those words, that's a great place to go. Okay. So the first example that we're going to look at is the next question, right after solving or right after vocabulary. Now, see, that's a little better. Here's the thing: the evaluating expression. What that means is to substitute for the variable for the given number, and then just use order of operations. People are making this way more difficult than it is. So this first example, if I can zoom in here a little bit, we're going to do one similar to it. Sorry, my lighting here again. I guess the green doesn't go up very well. So this is a negative 3 times a plus 2 plus 4 times b minus a. And what they're telling you is a is negative 2, b is 3. Okay? So what we're going to do is wherever there's an a, we're going to put a negative 2. And wherever there's a b, we're going to put a 3 minus negative 2. All right? And once we've replaced all the variables with the constants, we're going to use order of operations. Negative 2 plus 2 is 0. Negative 3 times 0 is 0. Plus 3 minus a negative makes that a positive, so 3 times 2 is 5. So now we have 4 times 5. So our answer is 20. Okay? If you're going to do this in a calculator and you have a negative number, my suggestion is wherever you're going to put that negative number, you need to put it in parentheses. If you don't, your calculator work is not going to come out correct. So just be very careful when you're going to plug in the calculator that you put it in the right order and that you clarify what's a negative, what's a multiplication, and what's a addition, and all of that. Okay? All right, so that's the first kind of problem. You'll notice these are not the exact same problems. I'm going over something similar to those that are on the test. Okay? So the next one says simplify the expression. So what we talked about in class quite a bit was put a box around or highlight or color or whatever. 3x squared. My x squareds are going to be in orange. my x's are going to be in yellow, and my constant will be in blue. So when I rewrite this, I get 3x squared minus 7x squared plus 4x plus 8. 3 minus 7 is a negative 4x squared. The 4x is by itself and the 8 is by itself. And so this would have been the simplified expression. All right? So whatever you need to use, whatever tool, whatever way, method, whatever you want to use, to put those together so that all of your like terms are like terms and they stay together. And all you're doing is adding and subtracting the coefficients. All right, so this next one. Just a tad, what's wrong way? All right, the perimeter P of a square, we've got a square. The perimeter is when you add up all the sides. So the perimeter is equal to, that's what it says there, 4 times, so we're going to multiply the difference of a number s and q. Okay, difference, if you remember from our words, difference means we're going to subtract. We're going to subtract s minus 2. This is an s, okay? And then write that equation, and there it is. All we're doing is putting the words into a variable equation, an algebraic equation. So it said the perimeter P, gave you the variable, of a square is equal to, that's that sign, and then it says 4 times, so 4 times, the difference, and we have to put that in parentheses, of a number s and 2. So that means we're going to subtract s minus 2. And that is our final answer. Alright, don't make those harder than they are. Just read the words and translate it into the math. Okay? Alright, then we got into doing some just solving. So we have 4 minus 1 equals 11. And from what we've been doing, you remember that we have to first get rid of, if there's something added or subtracted to the variable term, that's what we have to do first. So since this is subtract, we're going to add. And whatever we do on one side, we must do on the other. So we have 4r equals 12. Okay? Once you get there, if you have a number associated with the variable, a coefficient, we must divide by that number. So r, and we do it on this side, we have to do it on this side, is 3. So this is our solution, and we should check it. So we look up here, and we say 4 times 3 minus 1 equals 11. That's what we want to know. 4 times 3 is 12 minus 1, that is 11. It checks. All right? That's all you have to do. Follow the steps. All right, here's another one. This time we have variables on both sides. So what we've said is we want to take the smaller variable and put it to the bigger variable. So negative 3, and because it's a negative, we must add 3 instead of subtracting 3 to both sides. Again, one thing we've said is if you are have trouble remembering to do both sides, put that line down the middle. Whatever you do here, you have to do here. So now I have 15p minus 7, and this is 0, so it equals 8. And again, I've got something subtracted, so I must add, always doing the opposite. And when I have a coefficient in front of the variable, I must divide, and so p equals 1. So if we plug in 1 up here, sorry about that, 12 times 1 is 12, 12 minus 7 is 5. Negative 3 times 1 is negative 3, negative 3 plus 8 is 5. So that checks. That's as simple as a check as you have to do. Nobody has to, you don't have to rewrite things. Just go back up there to the top, put the variable in, and make sure that it works. All right, here's another one. This was called the literal equation. We have to solve for whatever variable is being asked. They're solving for C. So that means this is one we have to isolate. This is the one that has to be by itself. So in order to get that by itself, we first we first must subtract 4a from both sides. So we're left with 2c equals m minus 4a. You're right, you can't subtract an a from an m, so it just has to stay there. And now we have a number in front of our variable, so we must divide. So we have c equals m minus 4a over 2. You can leave it like that, or you can say m over 2 and then minus 4 divided by 2 is 2a. Either of those would be a correct solution. Okay? The trick to these is just figure out which one you want by itself and then just keep doing the same steps. None of these steps change. It's always going to be the same steps each time, and if you get used to those steps, you can solve any of these equations. Now, the last one has several steps in it, several parts to it. Oops, let's see if we just lined up there. James works for a hometown car wash, and he earns $48 per day salary plus $9 for each car he washes. So first we want an expression that represents the money James can earn each week if he works 5 days a week. So he makes $48 per day. So he works 5 days, and we're going to multiply that by 48 per day. Plus, he makes $9 for every car he washes. Let's say C is the number of cars that he washes. Okay? So here is our expression. And if you want, we can multiply that out. 48 times 5 is 40, 24, so that's 240 plus 9c. Okay? So that's A. Then he has a great week. He washed 35 cars and he worked 5 days. So how much did he get paid? Well, we know he worked 5 days at 48, and we already know that's 240. Plus, he got $9 for every car, and he washed 35 cars. Okay? So that would be 35 times 9. That's 45. 27 plus 4 is 315. Okay? So we have 240 plus 315 gives us 555. All right? 27 plus 4. Yeah. Okay. So he made 555 that week. That would be that answer. Okay? If you think my math is wrong, then just let me know, but I think that should be right. It's late at night. Alright, so next week, he got paid $465 for working 5 days. How many cars did he wash? Well, we're going to stick with our 240 plus 9c because he worked 5 days at $48 a day, and he gets $9 a car, and he made $465, right? We're going to subtract our 240. 5, 2, 25 equals 9c. And then we just divide by 9. So c equals, what is that? 18 times 2. That leaves us 25 divided by 9. 18, so that's 45. So that's 5, right? So he washed 25 cars. Alright? So we used our expression that we made. We know how much money he made, so we can figure out how many cars he washed. So finally, on this problem, one of the things it asks for is to figure out how long it would take him to save a certain amount of money. So let's say he wants to buy a new gaming system. It's going to cost $1,500. It's a really fancy one. However, they've cut back his hours to only 4 days a week. So if he washes 5 cars a day, how many weeks will it take him to save his money? So we're going to change our initial equation to this because he's only working 4 days, okay? And we need to know when that's going to be equal to $1,500, okay? So first we're going to look at 48 times 4 is 32, 60, 192. So this is 192 plus 9c equals 1,500. We'll subtract our 192. So 9c equals 8031. Okay? And then we got to do some long division. I know you guys love this stuff. divided by 9, so it's going to go in there once, so that's 40, and that's going to go in there 4 times, 36, and 48, so that is 5 times, so that would be 44, 3 left over. So he has to wash, at least he has to wash one more than this to get his $1,500. Okay, so C is equal to 145 points, about 3 plus or minus, so that means he needs to wash 146 cars. Oops, off the screen there. There you go. 146 cars, because he's going to make 145 and some change is what it needs. So in order to get that change, he's got to wash that last car. All right. So I've gone through every kind of problem that was on that test, and for those of you that scored not as well as you would have hoped, here's your chance, your opportunity to fix that. Like I said, you can do corrections, and that is basically sitting down and with the video going through the problems and seeing if you can match up exactly how to do them with the ones that I just went over again. Or you can do that and make sure, maybe do a little more practice and feel more comfortable and retake the test to get your full possible points back. All right? If you have any questions, come see me at class or in the mornings or after school.